Hello friends, now we see the problem number 7, which is a based on shift of origin of chapter Locus. The problem number 7 is if the equation x square minus 4x minus 6y plus 10 equal to 0 is a transform to capital X square plus ay equal to 0, axis remaining parallel. Find the coordinates of point when the origin is shifted and the value of capital A. Now let's see the solution. The solution is very simple. Now the given equation, that is called old equation of locus. So the old equation of locus is x square minus 4x minus 6y plus 10 is equal to 0. Now this equation can be written as x square minus 4x, then we write term minus 6y plus 10 and that equal to 0. Now if you observe the new equation of locus, so in that new equation we have capital X whole square plus ay. So here we have to make it first bracket as a complete square. So for that purpose we find last term. So LT is equal to 1 upon 2 into coefficient of x whole bracket square. So that is equal to 1 upon 2 into, now coefficient of x is here minus 4, then whole bracket square. On simplifying that, 2 ones are 2 and 2 twos are 4. So we left with minus 2 the whole bracket square, and that gives us the answer 4. So therefore the above equation can be written as x square minus 4x plus 4. Then the remaining terms are minus 6y and plus 6. Now plus 4 plus 6 gives us plus 10. So it means we split up 10 as a plus 4 and plus 6. Now that equal to 0. The next step will be, now x square minus 4x plus 4 is a complete square of x minus 2 the whole square. Then from the remaining two terms we take minus 6 common. So in bracket we have y minus 1 bracket complete is equal to 0. Now we let x minus 2 is equal to capital X and y minus 1 is equal to capital Y. So therefore the above equation become capital X square minus 6 into capital Y is equal to 0. So which is of the form x square plus ay is equal to 0. On comparing, we get a is equal to minus 6. So in this way, we get the value of a. Also, shift of origin h comma k that equivalent to 2 comma 1. So this is a required solution for the given problem. Thank you.